Hi, welcome to IEM Learning Chemistry classes. I am discussing on the topic of atomic and molecular structure. Today I am going to discuss about the quantum numbers. The quantum numbers are nothing but the identity of the electrons. If we wanted to know about you, then what we should know? We should know your name, your address, your qualifications, all those things. That is the identity. Your parents' name, that is the identity of yourself. So how we can know the electrons? The quantum numbers are nothing but the identity of the electrons. It defines the electrons. It tells everything about the electrons. So that is the quantum numbers. So what we are going to discuss? We will first discuss about the principal quantum numbers. Then we will discuss about the angular momentum quantum number, and we will discuss magnetic quantum numbers, and finally the spin quantum numbers. Along with that, we will try to understand how to actually tell the quantum numbers of electrons of s, p, d and f orbitals. For example, an s orbital can take 2 electrons, p can take 6 electrons, d orbitals can take up to 10 electrons and f orbital can take up to 14 electrons. So how to give the quantum numbers to each of the electrons of all these orbitals, that also we will try to understand today. So what is principal quantum number? We all know, after solving the Schrodinger wave equation by taking particle in 1D box concept, that the energy of the electrons E equals to n square h square by 8 m square. So this n is nothing but your actually the principal quantum numbers. N is nothing but, it is an integer and this is the principal quantum number. For example, let's say if n increases, what happens? N increases means the size of the orbitals increases, and as soon as n increases, in simple term, energy of the electron increases. For example, if n equals to 1, it is simply h square by 8 m square. If n equals to 2, it is 4h square by 8 m square. That means energy is increasing. So principal quantum number actually defines the energy of the electrons. As soon as it increases, the orbital becomes larger and the electrons spend more time further from the nucleus and energy increases. So electron is higher in energy. Higher energy means less stability, less tightly bound. So what does principal quantum number do? It specifies the energy of the electron. Principal quantum number specifies the energy of the electrons. For example, let's say one electron is present over n equals to 1, another electron is present over n equals to 2, another electron is present over n equals to 3. That means the energy of the electron which is present in n equals to 3 is much higher than the energy of the electron which is present in n equals to 2, which has more higher energy than the electrons which is present in n equals to 1. So energy is increasing in this direction as soon as n is increasing. So what is angular quantum number then? The angular momentum quantum number is nothing but, it actually tells about the shape of the orbitals, or it tells the angular momentum of the electrons. How it can have the values? If n equals to, if the value of n is 2, then L will be 0 and 1. That means it can have values from 0 to n minus 1. Whatever value n will have, L value will be 0 to n minus 1 for each value of n. It defines the shape of the orbitals. For example, let's say if we have L value 0, it is a s orbital. It is a spherical shape. If L equals to 1, it is a p orbital. It is a completely different shape. We will discuss shape of the orbitals in a separate class. I am just showing you so that you can understand that L, or angular momentum quantum number, actually tells the shape of the orbitals. If L equals to 2, then it has again a different type of shape. It is known as d orbital. So L value defines the shape of the orbitals. Again, if L equals to 3, it has f orbital which has completely different shape. And for we get specific value of n's, L can have 0 to n minus 1. So how to explain that? Let us take an example and you will be able to understand. Let us take n equals to 1. So if n equals to 1, what will be the value of L? It will have 0 to n minus 1. So n minus 1 equals to 0, so it will have 0, only 1 values. If n equals to 2, then what will be the value of L? 0 to n minus 1. So n minus 1 is 1, so 0 and 1. If n equals to 3, then what will be the value of L? L will have n equals to 3. That means L can have first of all 0, then 1, then 2, because it can have up to 0 to n minus 1. So n minus 1 is 2. So all the values 0, 1, 2 will be the values of L. Similarly, if n equals to 4, then L value will be 0, 1, 2, 3 up to n minus 1. If L equals to 5, n equals to 5, then L will have 0, 1, 2, 3, 4 up to n minus 1. If n equals to 6, it has 5. N equals to 0, 1, 2, 3, 4, 5 up to n minus 1. So L will have 0 to n minus 1 value, and correspondingly it will have different type of orbitals that we will discuss later on when we will discuss about shape of atomic orbitals. For example, if L equals to 0, it is F, if it is 1, it is P, if it is 2, it is D, if it is 3, it is F, it is 4, it is G, like that. And definitely what we can say that as soon as the L value increases for a particular value of n, the energy increases. For example, in 1s, n equals to 1, L equals to 0, but for 2s, n equals to 2, L equals to 0. But for 2p, n is fixed, but L is 1. So 2p has higher energy than 2s, which is higher energy than 1s. So the energy sequence is like that: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 8s. So this way energy increases. So if I ask, for example, 3p, it has more energy than 3s, which is more energy than 2p, which is more energy than 2s, which is more energy than 1s, like that. So definitely L value, if same n value is there, then more higher L value means more higher energy. We will discuss while discussing the shape of orbitals. We will discuss this thing again. That time it will be much more clear. And then we have magnetic quantum number. Now this is very interesting. If we have n equals to, let's say, 2, so L will have 0 and 1 value. So what will be the value of magnetic quantum number? It can have value up to plus L, including 0 to minus L for each value of L. For each value of L means, let's say L equals to 0. So what will be the ML value? ML value will be 0. But when L equals to 1, what will be the value of M? The MA or ML value will be minus 1, 0, plus 1, because plus L to minus L including 0. That will be the value of magnetic quantum number. Actually, this magnetic quantum number tells the orientation of the orbitals or magnetic moment of the orbitals. It tells the orientation of the orbital, how the orbital orient in the space. It can have values between minus L and plus L including 0. It describes the orientation of the orbital in space. How p orbitals orients? For example, we know that if L equals to 1, it is p orbital. So how many orbitals are there? How the orbitals are oriented in the space? Who will tell that? ML value or magnetic quantum number value will tell about the orientation of the orbital in space, how it orients, how it actually look like in the space. For example, let's say n equals to 1, so L equals to 0, M value definitely will be 0, that is the 1s orbital. Now if n equals to 2, L will have two values, one is 0 and another is 1. For L equals to 0, M value will be 0, but for L equals to 1, M value will be minus 1, 0 to plus 1, minus L to plus L. And what does this 3 number signify? The 3 ml value means it actually tells 3 different type of orbitals with different orientation. That's why P has 3 orbitals. We will see that during the discussion of shape of orbitals. If n has value 3, then L will have 0, 1 and 2. For 0, for L value 0, M have 0. For L value 1, M has 3 value, minus 1, 0 and plus 1. For L equals to 2, how many M value will be there? Minus 2, minus 1, 0, plus 1, plus 2. Because minus L to plus L, that you need to remember. Minus L to plus L, the values can go. That's why the minus 2, minus 1, 0, plus 1, plus 2. Again, ML has 5 values. So definitely the d orbitals will have 5 different orientation. Accordingly, their name will be 5 different names. We will again discuss this thing in the next video. So now, let us try to take one example and try to understand that how many number of orbitals, how many number of subcells will be there, how many orbitals will be there. Try to understand. Let us take, I am taking n equals to 4. For n equals to 4, how many L values will be there? 4 L values will be there, 0, 1, 2, 3. For 0, ml value will be 0. For 1, ml value will be 3. That means for L equals to 0, ml equals to 0, it has 1. That means number of orbitals is 1. For L equals to 1, m has 3 value, that means number of orbitals is 3. If L equals to 2, the ml value has 5, so number of orbitals are 5. If n equals to 3, it has 7 ml values like plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus. What is the meaning of 7 different values? 7 different values means 7 different orientations of the f orbital, because if n equals to L equals to 3, it is f orbital, and 7 different orientation means 7 different orbital. So L equals to 3 means ml equals to 7 different values, that means 7 orbitals. So in n equals to 4, how many orbitals are there? Total number of orbitals 3 plus 1 4 plus 5 9 plus 7 16. So 16 orbitals are there in n equals to 4. Now if each orbital can take 2 electrons, the total number of electrons that n equals to 4 can have, it is 32. And that's why we generally say that n equals to 4 can have maximum 32 electrons, because there are 16 different orbitals. And we can assign the quantum numbers for all the 32 electrons. We can assign the quantum numbers to each of them. We will see that. Now let us try to understand about the energy levels. As I told, 1s has lowest energy, then 2s higher in energy, 2p again higher in energy. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. So as soon as you are going, your basically energy is increasing in this direction. So that is also very important, that you should know how energies are increasing. Again, the electrons which is present in n equals to 1, it has lowest in energy. If the electrons which is present because n equals to 2, it has again two different orbitals, 2s and 2p. The energy of the electrons in 2p will be definitely higher in energy of the electron which is 2s. So this is nothing but it is showing how to actually get different values for different orbitals. For example, if we consider n equals to 3, then L have 3 different values. For L equals to 0, we have ml equals to 0, so s orbitals, it has 3s orbital because n is 3. For L equals to 1, ml has 3 different values, so there will be 3 p orbitals, right? There will be 3 p orbitals. Again, for L equals to 2, ml has 5 values, so 5 different d orbitals. 5 different orientations means 5 d orbitals. So now the fourth quantum number, which is very much important, which actually tells the because for sometimes the 3 quantum numbers for electron can be same, but the fourth one must be different. That makes the every electron unique. No two electrons will have the same 4 quantum numbers, because the spin quantum number will be definitely different for 2 electrons. That's make their own identity. Electrons can have 2 different type of spin. Either it can spin clockwise or anti-clockwise. Sometimes it is also known as plus up and minus up. So spin quantum numbers has fixed value, plus up and minus up. What is plus up and what is minus up? The plus up actually we can say that it is nothing but if it tells that upward direction, or you can sometimes the clockwise direction, and minus up which actually tells the anti-clockwise. So now we will see that what is plus up, what is minus up. The positive value is nothing but, as I told, it is upward spin, and sometimes it is also known as spin up, and the negative value it tells downward spin, or it is also known as sometimes spin down. Spin up and spin down. Spin up means plus up, spin down means minus up. That is the two different significance of two different values. So spin quantum number has fixed value, that is plus up and minus up for each electrons. So now for 1s electrons, there are only 2 electrons can present, so we can actually, as I told, no 2 electrons will have the same 4 quantum numbers. For 1s electrons, for this electron we have n equals to 1, for n equals to 1, L equals to 0, ml equals to 0, ms will be plus up. So for what will happen to this electron? All the 3 quantum number n, l and m will be same, but the spin quantum number will be different. This makes this electron unique. This makes this electron different than this electron. That's why I told that 4 quantum numbers is required to actually tell everything about the electrons. It makes them unique to tell their identity. So 4 quantum numbers are required to describe an electron, and no two electron can have the same 4 quantum numbers. No two electrons can have the same 4 quantum numbers. So quantum numbers, if we wanted to give the quantum numbers for all the 6 electrons of 2p orbitals, how to give that? So let us take first understand what is the value of n, l, m and ms. So definitely for 2p electron n equals to 2, as it is p, that means definitely it will have l equals to 1, because l equals to 0s, 1p, 2d and 3f. So if l equals to 1, ml can have only 3 values, minus 1, 0 and plus 1, and ms can have only 2 values, plus or minus 1. So how to give that? So let us, I wanted to give first the quantum numbers, all quantum numbers to these 2 electrons. So I can very easily give 2, 1, 0 plus up, 2, 1, 0 minus up. Similarly, next 2 electrons I can give 2, this will be 2 minus 1, 2 minus 1 plus up, 2 minus 1 minus up, because we have already used l equals to plus 1, so we are m equals to 0, we have already used ml equals to 0, so here we will use ml equals to 1. So 2 1 1 plus up, 2 1 1 minus up, right. Similarly for these 2 electrons, okay, it was actually rightly said. So we have taken this will take as a plus 1. So 2 1 1 plus up, 2 1 1 minus up, and this one 2 1 minus 1 plus up, 2 1 minus 1 minus, because ml have 3 values, so I have to take 3 values, right. L is 1, that is fixed, so 2 1 will be fixed, so only change will be the ml values and plus or minus up. Okay, so we have taken this one, ml has 0, this one ml has plus 1, and this is ml value is minus 1. So now you cannot tell that 2 electrons have the same 4 quantum numbers. All the 6 electrons have different quantum numbers. That's the beauty of these quantum numbers. It tells everything about the electrons. Now if you wanted to assign the quantum number for all 10 d electrons, we can very easily do it. Your first job will be to note down the value of n, l, m and ms, or ml and ms. So n equals to 3, l equals to 2, because for d l equals to 2. If l equals to 2, ml value will be minus 2, minus 1, 0, plus 1, plus 2, ms will be plus half and minus half. And accordingly you need to give all the 4 quantum numbers to all the electron. For example, 3 2 2 plus up, 3 2 2 minus up. Similarly 3 2 1 plus up, 3 2 1 minus up, 3 2 0 plus up, 3 2 0 minus up, 3 2 minus 1 plus up, 3 2 minus 1 minus up, 3 2 minus 2 plus up, 3 2 minus 2 minus up. So all the 10 electrons have different set of quantum numbers. That's the beauty of quantum number. Similarly, we can give quantum numbers all for 14 4f electrons, because I have taken one example. It's very easy now. I am showing it. Okay. Now let us consider. Okay, I am not. Okay. So these are the 14 electrons, and we can very easily say, because we know n equals to 4, l equals to 3. If l equals to 3, ml value will be minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, and the rest is same. First you need to take 3, then 2, then 1, then 0, minus 1, minus 2, minus 3, and all other things will be same. 4 3 3 plus up, 4 3 3 minus up, and so on. So accordingly you can give quantum numbers, 4 set of quantum numbers to all the electrons of 4f orbitals. So now we will take one example. Let us consider the all electron present in n equals to 2. We wanted to assign quantum numbers to every electrons of n equals to 2. First, your job will be to identify what is the value of l and ml. For n equals to 2, we have 2 l values, l equals to 0 and l equals to 1. So ml will have 0, and for l equals to 1, ml will have 3 different values. So altogether we have 8 electrons, and we can very easily summarize the 4th set of quantum numbers for these 8 electrons. For 2s electrons, what will be the value? We will have 2 0 0 plus up and 2 0 0 minus up. For 6 2p electrons, we will have 2 1 0 plus up, 2 1 0 minus up, 2 1 1 plus up, 2 1 1 minus up, 2 1 minus 1 plus up, 2 1 minus 1 minus up. So all the 8 electrons which are present in n equals to 2, we are now able to assign them 4 set of quantum numbers to all the electrons. So that's what why it is important, because it tells you actually the identity of the electrons. Because when we will do with theoretical calculation, that time these quantum numbers are highly important. When we will deal with magnetic properties, when we will deal with their optoelectronic properties, absorption properties, emission properties, that time these quantum numbers will help. Mainly it helps to tell various magnetic properties of various complexes, various molecules. That's why quantum numbers are very important, although it looks very much mathematical, but it has huge practical applications. That's all for this video. We will discuss about other part of this atomic and molecular structure in our next video. Thank you and see you soon.